I'm going to give you like sneak peeks basically to a lot of sessions that are coming up soon. And so today we have Dr. Danielle Wood, and we are going to talk about sustainability in space. She also has a session coming up later today at 1 o'clock.
That's right.
So keep that in mind. If you miss this, you only hear half of this, you can go to the session too. I realized all of yesterday I did not introduce myself at all. I'm Regina, and I'm going to be your moderator today.
Thanks, Regina.
Thanks. Usually work at NPR, but now I work at this table for the whole conference. But I'm here with you, and we're going to talk about space. I love space, right? So when you specialize in space exploration and making that, really like thinking about sustainability, but let's actually take a step back. And when you talk to people about space, you tell them about your research. What's like the first thing they think about when they think about space exploration?
A lot of people are aware of movies and stories about astronauts, and that's fine. But I had the pleasure to work at NASA and really see NASA's a great example of the whole portfolio across the space enterprise. We have amazing work we do in science, using satellites to study the Earth and also studying the whole solar system and really the deep galaxies and the whole universe. And there's also work in understanding what's happening from the point of view of how humans and materials and other plants and animals change when they're in space.
Right, so, we're thinking about science maybe happening on Earth, we're thinking about moving to, other planets, but what are people maybe missing in that picture of, like, space exploration? Maybe they haven't heard about.
The number one thing I want people to remember from my talk, if I could only have one message today,
yes,
is that this year, 2024, and the next few years, is really a key moment in a transition of our role as humans within the cosmos. The reason I say that is that we're going to start to do things that will have a long-term impact on places beyond Earth. And it's going to be not just in the scientific vein, but also in other forms, things that are done for commercial and sort of tourism and things that are done for interests that go beyond science, which I think is exciting, but also it causes us to need to pause and reflect.
Yeah, and you mentioned like, TV and movies and stuff like that. And I think many of us are like familiar with like the future and people are like putting bases on the moon and stuff like that. But you're saying that like our government, other governments, we haven't really totally figured that out yet.
And there's been a lot of great work, so I want to take people back for a little bit of history. This is important history.
Yeah.
So the first satellite launches in 1957. The Soviet Union actually claims this achievement of putting the first human-based object in space. It kind of scared everyone. People were excited, people were inspired. And right after that, a great thing happened, which we should all be thankful for, is that a lot of diplomacy started to happen. It is the Cold War, and there is a lot of tension and constant concern about nuclear war. To be very honest, we could have had a response. The U.S. might have sent a nuclear war in response, to this kind of new thing happening in space, right, with Sputnik launching.
Yeah.
So thankfully, instead of that, diplomats come together and say, this is an exciting new era of human activity in space. What we'll need is international fora where even in the midst of the Cold War, we can have coordination across the key players. And a few things were formed, like a United Nations Committee on the Peaceful Uses of Outer Space. They started to develop treaties, so in 1967 and going forward, you have several treaties, and many countries signed them. Initially, the US, USSR, the UK, and others. And then gradually, even until now, the committee still exists. And now it's like 100 countries involved from every single continent.
It's on this treaty.
I would say they're on the committee first that forms it, and then many of them sign it. And the good thing about treaties, they matter when a country makes it domestic law. Because international documents exist in the international law space, but they're really enforced when they become domestic law. So countries like the US have made it our national law too. So the US government follows these treaties, the ones that they've ratified, as national law.
Okay. So we have some base for like if we like go off and want to have a base on the moon or a base on Mars.
Good point. One of the key things the treaty says is that actually no country can occupy in terms of claiming territory and space, so on the moon or other celestial bodies. It says celestial bodies. But everyone is free, every country is free to access these facilities to do scientific research in peaceful purposes.
Okay. And so what is your research? How does your research kind of Venn diagram with this? Like how do we do this sustainably? I can't talk. It's so early.
It's early, but you're here with me. A great way to describe my research is that I'm asking, how are we fulfilling the promise of some of these treaties? The treaties say beautiful things like, space is the heritage of all humankind, and every country, no matter their scientific or economic background, has the right to benefit from space. So then I want to ask, how well are we doing that, and what needs to change to make that a reality? I'd say there's great progress, but more work needs to be done in several different spheres. So part of my work is laying out an agenda for multiple kinds of research that need to happen to make that reality.
Tell me some of those things that need to happen.
Yes, the number one.
These positive things, we're going to do it.
We're going to say a positive thing.
Yeah.
I'd say what's great an example, where you see a lot of good progress and then more work is needed, is the idea of using satellite-based services to serve needs that are directly addressing the Sustainable Development Goals. So hopefully people are familiar with the SDGs, Sustainable Development Goals.
I don't think they are, but we should explain
I will
them.
explain.
Yeah.
So the United Nations curated, with actually many representatives across many countries, but also sectors, a list of visionary statements that should last between 2015 and 2030. And they are the key challenges of our era. I mean, some of the obvious, number one, the obvious one is to eliminate extreme poverty, to address the needs for food security, energy security, water, to address climate change, to include gender equality, and consider how we consume and produce materials. So the idea is that if you look at the list, it's 17 big statements, but they have actually many quantitative indicators, ways to measure our progress at the national level. But many could be adapted to a company or to a city as well. I know leaders in every country around the world who are working on making it possible to use these tools to help evaluate their own progress for sustainable development.
So like how, can you break it down for me? Like how is a small satellite that's taking data of the Earth going to help with those sustainability goals?
What a great question. So
Thank
part
you.
of my work is spending time asking, how can we use data from satellites? And there's different kinds of satellites, right? This is great. So I used to work at NASA's Earth Science team, and NASA, similar to what they have in Europe and also Japan and India and China, these governments are operating satellites, taking pictures, but also, more interestingly, taking measurements, not necessarily just photos, but they measure what's happening in the ocean, like the temperature, for example, and what's happening in the atmosphere, like the concentration of CO2 or carbon monoxide. And they measure what's happening at the polar ice caps, like the pattern of melting and refreezing. And they measure what's happening with our crops. These measurements make a great data set, but to be honest, it's actually hard to use the data.
Yeah.
It requires typically a PhD in these specialty areas of ice monitoring or ocean monitoring. So part of my special work as a system engineer trained in aerospace engineering is to focus on translating the results of these really interesting satellites with interdisciplinary teams that have scientists and social scientists and policymakers, and we make information tools that use this data to answer key questions for the SDGs.
Okay, so you're basically like, you're getting all this data and you're making sure that people can actually understand them and utilize them for like agriculture, utilize them for building, all that kind of stuff.
Great examples. Right now I have active projects led by teams in Angola, Ghana, Benin, Brazil, Indonesia. And in these countries, each team has had a particular interest. In Ghana, we are working on mapping mining, both legal and illegal, and sometimes there's deforestation. So we're tracking where there's been loss of trees using different kinds of satellite data. Some is like pictures, and some is more like radar and LiDAR, laser measurements. In Angola, we're using NASA data, which measures soil moisture using microwave radiation. And we're helping them think about responding to drought concerns.
We just did a story at Shortwave, the podcast, and we said that we use satellite data and AI to like find out where there's like illegal fishing and like legal fishing and stuff and overfishing. So like you're saying like this data from the sky can really tell you a lot about like how you can manage what's happening in your country.
The data from space is very helpful, and what's great is also to mix it with data from what's happening on the ground. So when I say I'm working with these teams, it means they're also bringing their local insights. The teams in Ghana are carefully helping us compare our satellite data with their local knowledge. So I do want to say I love the data from space, but it's always needing to be combined with data from the ground.
It's supplementary, yeah. And so you're talking about these satellites. Can you kind of explain to our audience like the difference between these satellites and maybe the satellites from like SpaceX and like their networks that they're putting up in space? Like how are they different and how are they differently affecting our communities?
Sure, I could talk about a few things. First, I'll mention my own TED Talk, because it's a nice introduction. It goes into more detail. In that TED Talk, I say there are 6 different technologies from space that I want to explain and then further show how each is different and how they affect society and the SDGs.
Yeah.
So for example, I've been talking about satellite Earth observation. We also have many satellites that we use for communication, so that could be internet access, TV broadcast, and of course there's a whole set of great satellites we use for positioning. So when we get our position information on our phone, that's coming from a network of globally operated satellites by different countries that our phone can read and understand where we are. I also mentioned in my talk microgravity research,
Yeah, that's really
basic
cool.
science research, as well as technology transfer. So if you go to the TED Talk, you can get the whole detailed. But I'll just say, what's important to say now is that I also work a lot on the question of how can we have so many great satellites safely for different countries, right? The United States, my wonderful country where I've been in for my whole life and my family's been in for many generations.
Where we are right now.
Where we are right now. I love the US. We are putting a lot of satellites in space.
Yeah.
You might say per country a lot in terms of our share of the use of
Capita.
space, right?
Yeah.
And so if you look at other countries, they also would like to have satellites. They don't want to just assume that the US will always provide certain satellites, because if you're a country, you can't just assume other countries will do things for you.
Right.
It means that according to the treaties we mentioned, every country should have the ability to concern that they have their own needs met from space. But it's true that when countries and companies in the U.S. Or other countries would like to operate a lot of satellites, it impacts the risk for other countries that want to operate their own. And right now, the U.S. has some interesting experiments happening with companies operating large constellations. Now, they bring great, interesting benefit. There's a company called Planet that's using hundreds of satellites to take a picture everywhere on Earth, especially on the land, about every day. And there's companies like SpaceX operating large constellations of communication satellites to try to spread internet access. And of course, I believe in the value of trying to use space to provide these services. And we have to do some good innovation now on what we call space sustainability and safety. So part of my research asks, if everyone's going to benefit from space, how can we coordinate on what's called space traffic management?
Yeah.
I'll soon be going to host a conference on this with collaborators at multiple universities. And we have to figure out a future where, just like we coordinate with planes these days, that's happening already, there's air traffic management, but we don't yet have the equivalent in space for international coordination to make sure that when I operate my satellites at certain altitudes, it won't affect other countries' satellites. Right now we do it a bit ad hoc, and there's some work by the US military to make sure that we try to avoid collisions, but there's not a central space traffic management system yet.
Yeah. Are collisions common?
Well, let's say what actually is happening is that there are teams, in this case the US military plays a key role, they watch with their different systems. You can use optical systems and you can use radar to try to track things that are in space. And what's happening is possible collisions are constantly being potentially found, meaning there's a team that actually has a list of things that might be collisions today. And they basically call the operators and say, look, there's some probability, some number, that you might have collision, just be aware of that. But there's so many of those that actually for the operators of satellites, it's hard for them to understand all of them. Like here's 100 things that might happen that could be a collision, and a few of them are really important and a few we can ignore.
Right.
So what's real is there's not as many collisions, there's many potential collisions, and that causes work for everyone to evaluate what's really a risk and what's not a risk.
Okay. So back to your research. So you're doing, you're looking at all these different countries being able to use data from the ground, data from space, trying to help these, try to get towards these sustainability goals. What is not happening now that you would hope will happen in the near future? Like, what is your next new excited thing, next step?
So there's a few things we're doing. One is that my team has helped be part of an international cooperation called the Space Sustainability Rating, and it's a way to help emphasize the behaviors that operators in space can take to try to reduce space debris.
Okay.
So I want companies to voluntarily pay to get rated, just like many companies in the US do or other countries when they want to show their building is a sustainable building. Maybe you've seen a building that has a LEED symbol on it. It's kind of like we're trying to make the LEED for space, where you say, look, I've paid some extra money to both have the right design and to measure that I'm trying to reduce space debris and space collision risk.
And you talked about this last year.
That's right. If you check out my Sci-Mic talk from last year, you can see details.
But have things changed? Have things actually advanced since last year?
I'd say this is a slow process, so in some ways it's going to be a long journey. Okay. But what's exciting is, so one question that you can explore is, what's the current dialogue and what are the current challenges around having large constellations, and what's working well and what's the challenge?
Yeah.
I'd say what's working well is that there certainly are policy actions being reviewed. I'll take the U.S. example where different teams from the White House and from Congress, they're indeed asking, what should we do right away to consider how to do what's called mission authorization, meaning mission authorization means, according to these treaties, the U.S. government and any government is responsible for giving permission for any commercial or non-government operation of a satellite in space or a mission in space. So there's definitely work happening to review what the rules should be, and that's exciting. And then I think, again, things happen slowly but also fast in space. It's going to take us years to really build a culture in the space community. But we are indeed seeing new companies getting rated, and we're seeing constant academic research. The thing I want to see is, to be honest, more funding for academic research to really ensure we have the right science knowledge and policy knowledge on these topics.
Do you think that companies that will be rated, the companies that have a stake in this, that want to be seen doing this in good faith, could they be giving money? Are they giving money to this research?
This is a great question, actually, because one has to be a little careful as a university team.
Yeah.
Should we take money directly from the companies we want to also encourage to rate, or is there a conflict of interest there?
Yeah.
We worry about that, so we try to be careful to channel funding. I believe it's a public function. I think the company should pay to get rated, and that the government should pay for the research so that it can be without conflict of interest.
I see.
It's a question we constantly wrestle with.
Yeah, that's hard, because they have the big bucks.
Hey.
Oh my gosh. Okay. And with this I think we have one more minute. I'm going to ask you, what are you most excited about at this conference? Have you done anything awesome, or are you going to go do something awesome? This is a new question. I did not ask this last time.
So I'm so thankful to be at AAAS this year, and I love the theme of Science Without Walls.
Yeah.
When I come here, I'm bringing my experience from the space community, but I'm meeting with friends and colleagues who are in the broader science policy community, and we're finding connections between things we need to exchange. ways that my knowledge about the space community can be influenced by ecology issues on Earth or questions of biodiversity. They're not totally separate. These are examples where we need the public sector to come together with companies and nonprofits and universities to really creatively innovate the future we want to have. I teach Introduction to African Diaspora Studies at MIT, and part of what I'm asking my students to do is to learn tools in a technical field, to find a source of wisdom they can believe in, and then to become leaders in a field, because we need leaders of the next generation in every field to help us solve these complex issues.
Yeah, I'm going to go to Meow Wolf. Nobody gets that. That's fine. Thank you so much, Danielle and Dr. Wood. And I hope you do find the next generation and encourage people to help you. Thank you so much.
Thank you. It's a pleasure.